Oh, science, yeah.
The ocean is heating up almost everywhere. Then you reach the North Atlantic. Red, red, red. And just south of Greenland, blue. This blue patch should not be here.
I noticed that there's like a lot of red, and there's blue in the center.
I have no idea what that would be.
That blue, I feel like it looks like melting ice.
Reasonable guess. But this map is not showing sea ice. It is showing change. And this patch has actually become colder than its own past, while much of the ocean around it warmed. So, what is happening? Scientists call it the North Atlantic cold blob, or the warming hole. One sounds like a cartoon villain, the other sounds like a typo. To crack it, we need a heated pool. Imagine a heated swimming pool. Most of it gets warmer, but one corner stays cool. Is that corner somehow making cold, or is the warm water simply not reaching it?
Where is the heat coming from? Also, where is it leaving?
That's what
I think it's probably just going in one direction.
maybe you have like some jets or something in the pool that like push water away from that corner.
Exactly. Ocean currents deliver heat on a planetary scale. One major network is the Atlantic Meridional Overturning circulation. Yes, every syllable. Luckily, we can call it AMOC, pronounced AMOC. So, how much water does AMOC move? 5. Amazon rivers? 20 or 75? Lock in your answer.
I have no idea, maybe 75.
Yeah, 75.
It moves roughly as much water as 75 Amazon rivers.
That's more Amazon rivers than I thought it'd be.
That may be the understatement of the video.
It's just an immense amount.
Here is AMOC in 15 seconds. Warm, salty water moves north near the surface, carrying heat with it. Along the way, it releases some of that heat. As some of the water cools, it becomes denser and sinks. Far below, deep water moves south.
The heated water like circulates like somewhere else or something like that.
Textbooks draw one tidy conveyor belt.
It's kind of directed or streaming in one direction, and it's not dispersing enough.
The real ocean prefers branches, swirls, and detours, so let's isolate just one piece of the physics in a tank, same temperature. One difference: salt. The clear water is fresh. The blue water is salty. Watch the blue water. It sinks. This is not a miniature ocean, it shows one rule. Saltier water is denser, so it sinks below fresher water. That is the physics. Now add Greenland.
As the ice melts from global warming, then it's definitely going to provide fresh, colder water.
Its melting ice sheet, rainfall, and Arctic water all add fresh water here. Fresh water can form a lighter surface layer, making it harder for surface and deeper water to mix, and potentially changing currents that move heat. A 2026 study asked whether this patch was simply losing extra heat to the air. The numbers did not fit. Changes in ocean heat transport fit much better. In plain English, less heat has been arriving. Case not closed. Zoom in closer to Greenland. If fresh water cools the surface, what happens underneath? Colder. No change. Or warmer? Lock in your answer.
Maybe no change.
Or like, if this is like some closed system and like heat has to move, then I'd expect it to be warmer, but I'm not sure like...
Warmer water. If the top is cooler, then I'm assuming the heat went somewhere else.
That is a smart guess. One 2026 climate model experiment added meltwater. Parts of the North Atlantic surface cooled, while water below ended up about 1 degree Celsius warmer within a decade in specific places near Greenland. Why? Fresher surface water strengthened the layering and reduced mixing, so less cold water moved downward. Those were specific modeled places, not the entire cold blob. Across the broader region, long-term heat content has fallen through, much of the water column. So does this blue patch prove AMOC is collapsing? Winds, storms, natural cycles, and other current changes shape this region too. Scientists expect AMOC to weaken as the climate warms. But how fast? By how much? And exactly where the cold blob fits are still uncertain. The blob is a clue. It is not a live collapse meter, and if all of this has you picturing the day after tomorrow, pump the brakes. Great disaster movie, terrible stopwatch. But slower does not mean harmless. Rain and storm patterns could shift. Parts of North America's Atlantic coast could see additional sea level rise. And Western Europe, not an instant ice age. With a gradual AMOC weakening, it would still warm overall, just more slowly than it would otherwise. One blue patch in a warming world. Global warming does not paint every place red. It can change how the planet moves heat. The cold blob is a clue that one of Earth's biggest heat-moving systems may be changing. So I asked people what surprised them most.
I think the 75 Amazon rivers. I didn't know that before. Yeah.
I would say it's the warmer water hiding below the cooler surface because it's something you have to think about rather than something that feels like common sense.
Your turn. Team 75 Rivers or Team Hidden Heat? Comment your team and subscribe. The ocean is not done being weird.